There we go. So that's the problem, the shortest distance from a point to a plane. So we're given the point and we're given the equation of the plane. We're going to work out what to do there. So let's go, written the question out here more specifically with numbers. So we've got to find the shortest distance between the point 1, 1, 1 and the plane x plus 2y plus z equals 1. Now, the key to this is using the projection formula. And I'll get to that in a minute. But what we need is, we need another point in the plane. We'll call that point A. To find another point in the plane, so that means that line there will be in the plane, we just put find any point in the plane. So we just want to find a specific point in the plane. For this case, use something easy, x equals y equals 0. Then using the formula, you'll get 0 plus z equals 1. So therefore z equals 1. So we know our point A is going to be x, y, z. So 0, 0, 1. The next thing we want to do is we want to get that vector there. Once we get that vector, we'll do that first. Try and use some colors here. AP, the vector AP, you basically subtract the 2 points. So it's going to be OP in vector notation minus OA. I've got a couple of previous videos which deals a bit with this so that you can have a look at them as well. But basically, you're just seeing how what the change is from one point to the other one. So this vector is simply 1, 1, 0. That's the vector AP. And what we're going to do is we're going to figure out the normal to the plane, and then we're going to project AP onto that normal direction. So since the plane is x plus 2y plus z equals 1, the numbers in front here of the x, y, and z give you the normal of the plane, or a normal of the plane. So that's easy. And from there, we can use our projection formula to see how this projects on to that, which is going to give us our vector. We're going to call this BP. So BP, using the projection formula, is the projection of AP onto N. And the formula, if you may or may not recall, there is another video on this. It's like this. It's AP dot N over N squared, where N is the magnitude of the vector N in the direction of N. What you do now is dot product. So dot product, you put 1, 1, 0 in there, dot product with N, which is 1, 2, 1. The magnitude of N is just the magnitude of N, which is the square root of 1 plus 4 plus 1. So that's the square root of 6. 6 squared is 6. Put that there. 1, 2, 1. And then the dot product, I'm going to run out of space down there, but we'll just sneak it in here. It's you multiply these guys together. So it's 1 plus 2 plus 0 over 6. And that becomes a half. So it's a half, 1, a half. And therefore, we'll slip it into this little box here. Therefore, D, the distance we want, equals the magnitude of that vector. And the magnitude of a vector is the square root of a half squared plus 1 squared plus a half squared. That's a quarter, 3 on 2. So root 3 on 2, or if you multiply by root 2 on 2, you get root 6 on 2. People like that better, don't they? I don't mind either way. So it's root 6 on 2 units. And that's it. Done deal. Now, that wasn't too difficult, was it? But as I said, there are some previous videos which explain projection formula and also the shortest distance from a line to a point. And if you have a look at those two, they might clarify any issues you have from this one if I went a little bit too fast for you. And I'll just